All right, so let's take a look at this assignment. It says stacking bricks. Problem one, a flat triangular stack. In this problem, you're stacking bricks according to the pattern shown at the right. Each row contains one more brick than the row above. How many bricks will be in the stack when it is 50 rows high? So it says you can solve the problem easily by creating a polynomial model to describe the number of bricks in the stack. Given a number of x rows, of rows X. Look for a pattern using a small table, press stat enter to enter the numbers L1 as shown. I'll show you how to do that. L1 is going to be the number of rows in the stack, and L2 is the number of bricks in the stack. So we're looking at it from the front. So really you should be picturing just like you see here is a two-dimensional model. So it says, which polynomial model should you use, linear, quadratic, cubic, or quartic? To decide, calculate the successive differences. Enter the first differences in L3, second differences in L4, and third differences in L5. Okay, so this is what we're looking at, basically. So here we have row one. Okay, so this is row one. So we could say this is n equal 1. Although if we're using f of x, we'll just call this x equal 1. So this column here are your x's. And then the output, actually, this is x equal 1. So let me erase that. So that is row 1. So in row 1, you only see one brick. And that is actually your output. F of 1 is a 1. Okay. The next, so we could even shade that in. Might be worth shading it in, so we know that that's the first row. Okay. Now, what we're gonna look at adding is a second row, but that in and of itself is it's telling us that we're adding a second row. So that's definite. And that is what the entry is. But look at what the output is. The output is the number of bricks in the stack. So we're actually looking at the whole stack once you add the second row. So the whole stack is now a 3. So that's actually you added 2. You did add 2 bricks in the second row, but what that amounts to is 3. And as I move this, things might get a little bit moved, but maybe I'll just try to add it down here. So we'll put that over here. So this is going to be, you added a second row, or you could say there are two rows, right? This is the first row, this is the second row. So there are 2 rows, and so there's 3 bricks in total. Now, if you add, by the way, so this is going to be f of 2 is 3. Now, if you add a third row, or if you want to interpret it by saying there are 3 rows, then now if you count all the bricks, that includes these plus the previous ones. So the output I know I'm running out of space here, but the output is going to be 1, 2, 3, 4, 5, 6. So this is going to be 6. Okay, now because of space and I don't want to delete everything, I'm not going to add the next one, but you might intuit that it's going to be 4. You're adding 4, but you're adding 4 to the previous 6, so it's going to be 10. So I mean, I can definitely draw the next one, or at least fill in, and I can actually write it over here. So whenever x is 4, in other words, you have 4 rows, f of 4 is 10. Okay, now they're asking you to compute the first differences. So that would be 3 minus 1, which is 2. 6 minus 3 is 3. And if you remember, well, we could see it up here. The next one's going to be 10. So 10 minus 6 is 4. So the first differences are, I mean, you see a consistent pattern and you can imagine that it keeps going, but they're not identical. Now, if you go to 3 minus 2, you get a 1. 4 minus 3 is a 1. And that pattern continues. So the next one is going to be a 5 and a 4, and it's going to be a 1. And then the third differences are 0, but we're going to stop here at the 1. So I'm going to go ahead and clear the screen so that we can keep reading. And it says, I want to read down here. If the first differences are constant, close to constant, then it's a first degree linear model is a good fit. That wasn't the case. In fact, I could quickly fill it in. It was 1 and then 3 and then 6 and then 10. Now I have space to fill in the rest. This is going to be 15 and this is going to be 21. And the first differences were going to be 2, 3, 4, 5, and 6. And the second differences are all 1s. Okay, so that's not the case. But if you keep reading, if the second differences are a constant, the second differences, then a second degree or a quadratic model is a good choice. So these are all the same. Those are constant. So we're gonna go ahead and use a quadratic model. What set of differences is constant? So that's gonna be the second differences. And what degree of polynomial best fits the data? So this is gonna be a quadratic. Now I'm just jotting things down quickly. I want you to answer the questions in a complete sentence for full credit. Okay, so that said, I believe the next question is going to ask us to come up with equation. So the way we're going to do this, we're going to go ahead and put this information inside the calculator, and I have my calculator ready to go. We're almost ready to go. I'm going to go ahead and erase those drawings. Okay, so I'm gonna go into my equation editor and I guess I need to quit. I need to clear all that. So I'm gonna go to my I'm sorry, my table editor, and I'm gonna put in L1. It's gonna be the number of rows. And I think if we go that far, we should have plenty to work with. Then if you're following the pattern, you see what's happening. Hopefully you can refer back to the picture to see where I'm getting these values. And then we don't really have to put in the first differences and second differences for what we're about to do. So I'm just gonna quit for now, and then I'm gonna go, we could turn on the scatter plot. Oops. We could turn on the scatter plot to look at the values. So let's go ahead and do that, to look at the points on the graph. And I like the zoom 9 because it gives me picture. You can see a little bit of curvature. It's really not linear. If you look closely, you'll see that it's not linear. So I'm gonna get out of that screen, and I'm gonna go to stat, calc, and I want a quadratic regression. And I want it stored for me in Y1. We're gonna go ahead and it is stored here, but I like the way, whoops, I think I'm gonna have to redo it. So stat, calc, quadratic regression, and it's already stored, but we'll go ahead and have it redo it. Okay, so we'll compute it. I like the way it is here because what it's giving me is an equation that I can use, and it's basically the function f of x. I know they're using a y, but we'll use the f of x is equal to, now they're using a 0.5. I'm gonna use a 1/2. Same thing. X squared, and my b is a 0.5 as well. X. So you can actually probably see that you can write it this way, or this is another way that we write this equation. Either one of those represent the same thing. You can slow down the video or rewatch it just to see that everything's related. There is no C, by the way, so that's why I didn't add anything here at the end. So that's the equation we get to work with. And then let's just go back to the problem, because I think after that, you have to find the R squared value. So we could do that here in a second. And then you have to do some predicting for number 5. So I'll let you complete this by doing number 5, but I will show you how to get the R on here. What we want to do is we want to turn the diagnostics on, and I'm going to look for that here. We're going to get we're going to turn the diagnostics on, and then we'll go ahead and calculate the quadratic regression again and see if it gives us more information. I'm just going to compute it. So the R squared is 1. The closer to 1, the more precision there is in the match between the equation and the points. You can see how closely it matches there. So that's the first part. Okay, and there's some other pieces that I didn't complete with you, but you can complete the rest on your own. I'll let you work on number 6 and number 7 as well. I just wanted to give you a basic idea. Okay, so the next one, the next problem says, in this problem, you're stacking bricks and pyramids. The diagram below shows the stacks from above. To see the pattern more clearly, the layers of the pyramids are shown separately below. I feel like it's a little uh, like the pictures are not being helped by the fact that they're not three-dimensional. So I wanted to get some dimension in there. Basically, what we're doing is we're taking um and I'm gonna eyeball the drawings so they're not gonna be perfect, but basically you start off with a cube and then you start adding cubes. You start adding cubes and it's a little bit, I think I'll add them in this way. So you start adding cubes to the bottom row. It's almost like steps, I would say. Um, so we could add one there. Then we can add another cube um, here. So I've added two, and then I'm gonna add one beside it and one in front of it. So if you're able to follow um, my kind of crude drawing, what you're seeing is there was one on top, and then what I've added, and I don't know if shading will help, but I can certainly try to add a little bit of shading. I've added, this face, another face here, and then, you know, I've essentially added four. There's one behind here as well, right? So I've added four cubes. So we have we have two layers now, two layers, and we have a total of four plus one, which is five. So when you simply had one, when X was one, you had the output was one. But now that you have two layers, and if you count all the bricks, you actually have the one on top and then the four underneath it. So that's five, okay? And by the way, notice that that this here and of course, I'm doing my best here to eyeball things. But this object here is a perfect square because it's a 2 by 2. So that's kind of important. The bottom is a 2 by 2. Now what I want to do is extend this out a little bit more for the next row. And so I'm gonna add one more brick out this way. I want one more brick out this way. And then there's the one that's beside it. But I want to come out one more this way. So that new layer, hopefully you can see that it's a 3 by 3. There's some hidden pieces obviously that you can't see, but so we have 3 layers And so when you plug in a 3, and if we count all of them, all the bricks or all the cubes, it's the 3 by 3 on the bottom, which is 9, the 2 by 2 in the second layer, which is a 4, and the 1 by 1, which is here. So total it's going to be 9, 10, 11, 12, 13, 14. And I think just for the illustration, I'm going to do one more. So we'll just add those, but I also want to go this way, right? And hopefully everything will kind of come together here in a minute. And you'll be able to count how many total bricks or cubes are in that layer. And I kind of like going over it with this just to kind of clean it up. So if you're following, you're gonna see that there's actually that this is a 4 by 4, which is 16. So since I'm just adding to the previous one, when I have 4 layers, then f of 4 is the 16 plus the 14, which is 30. So we can look at the outputs. We might as well look at them over here. If I take first differences, 5 minus 1 is 4. 14 minus 5 is 9. 30 minus 14 is 16. So let's go one more. That's the first difference. The second difference, 9 minus 4 is 5. And 16 minus 9 is 7. I think we may need to go one more just to complete the illustration. So x equals 5. Now I'm gonna just kind of make this a little smaller so we can fit in one more, at least one more example here. Maybe we can do one more, but when you plug in a 5, I'm not going to draw it, but the next picture is going to be 25. So I'm going to add 25 to the previous 30. So this is going to be 55. So the first difference is going to be 25. The second difference is going to be 25 minus 16. I'm going to go ahead and do the computation. So 9. So it's 9. Now, the third difference, 7 minus 5 is 2, 9 minus 7 is 2. We might as well do one more since we have some space just to see if that happens consistently. So the next one is going to be 6. I'm not going to draw it. We can just guess at what the next one, just use our understanding of the pattern. The next one is going to be 36, and I'm going to add 36 to the 55. So 36 and 55. 5, 6, 7, 8, 9. So it's 9. So it's not, I'm getting 91. So f of 6 is 91. Now subtracting 91 and 55. I guess we're also seeing a pattern here. These are the squares, right? So this could be 36. 36 minus 25 is 11. And look at the third differences. We get a 2 again. So if you need to convince yourself of the fact that this pattern repeats, you can go down to the next one, which would be 49 and so on. So let's go back to the problem and choose so it says choose and perform a polynomial regression and record it here. Now we're looking at the third differences being the same. I'm trying to see if they tell us. It says and so on, right? So yeah, I'm looking over here just so the second if the second differences are the same. No, I'm sorry. If the first differences, then we have a first degree. If the first differences are the same, then we have a first degree polynomial, which is the line. If we have second difference is the same, then it's a second degree. So then it says so on, right? So then if the third differences are the same, then it's a third degree. We don't have a special name for it. It's just the third degree polynomial. So what we're gonna do, because they ask us on this one, to choose and perform the right polynomial regression. So we're gonna do that in the calculator. Okay. All right, so I'm gonna go in and put in the new data. So I've got to clear out all this data from the previous problem. And then it's 1, 2, 3, 4, 5, 6. That was seemed to be far enough. And then when you have one layer, it's just one brick. When you have two layers, it's the 2 by 2 plus the 1. In other words, 4 plus 1, which is 5. Then it's the 3 by 3, which is 9, plus the previous 5. So this is going to be 14. Then it's the 4 by 4, which is the 16, plus the previous 14. That's 30. And then it's the 5 by 5, which is 25, plus the previous 30. That's 55. And then the next one is 6 by 6, which is a 36, plus 36 plus 55. And so let me put that in. And I'm going to just cheat a little bit and do 36 plus 55 and let the calculator do that for me just because I'd forgotten what it was. Okay, so then I'm going to go to the home screen and then I'm going to calculate a cubic. I said there was a name for it, but it's cubic. Sorry, it slipped my mind for a second. It's a cubic regression. And I'm going to go ahead and run it. Values are in L1 and L2. And we want to go ahead and store it in Y1. So we'll replace what was in there. And then we'll go ahead and calculate it. And so I'm going to write it down in a way that makes more sense to me. So this is f of x is, I'm going to write it down here because I need some space. So it's 1/3. Instead of 0.3 repeated, I'm going to use 1/3 x cubed. And then it's the b is a 0.5, so that's a 1/2 x squared. And then the c is 0.16 6 repeating, so that's 1/6. 1/6x, and then it gives you this value for D. It basically it's 1.5, but it's preceded by 11 zeros. Basically, they're telling you that's a zero. So we're gonna not use anything for D. Now, this form is fine, but I'm gonna go ahead and multiply this by 2/2 and this by 3/3. So that leaves me with 2x squared plus 3x squared plus 1x, and all of them are now going to be over 6, right? 2/3, if you reduce it, it becomes a third. 3/6, if you reduce it, it's a half. And so the reason I do that is because I sort of like this form of it. Even still, you could factor out the x if you want and write it. Oh, this is a 3. And write it this way. This is probably not the favored way to do it, but I'm just showing you different ways that it might work. I guess my favorite one would be this one here. And if it's already in here. And if I do zoom 9, those are the points. And let me zoom out just so you could see that it's indeed a cubic. So that's a full cubic. One thing to keep in mind if they ask you about the domain, because we're talking about stacking bricks, it only makes sense for positive x's. Let's take a quick look and then wrap this up. I think that's the regression equation. I don't know if it gave me an R squared. You might have to turn the diagnostics on, just like we did before. I'll let you do that. Total bricks versus number of layers on our scatter plot. We already did that. And then use it to calculate the number of bricks in a pyramid 50 layers high. Now you have an equation you can work with. And then it's got some other questions, including a question about domain. So that should be plenty of information for you to complete the questions that we didn't address. And hopefully this gave you a good understanding of this project.